Hi, my name is Dan. I'm a former University of Birmingham undergraduate. I am not an academic like the majority of people are doing these talks, but I do like astrophysicists. And over the course of this talk, I'm going to talk about the ideas of how we can handle lockdown like an astronaut and what that really means and whether we should aspire towards it. But we'll get to all those points soon enough. For now, let's just go on a journey. So who am I? Like I said before, my name is Dan. I'm a former big name in physics of the Poynting Physical Society. Watch this space, I'll win it a third time. I am also quite a close friend of AstroSoc Committee. I've done quite a few talks on dark matter, arguably too many by this point. I liked dark matter enough over the course of those talks that I'm now a PhD student just starting in the University of Oxford, working on the LZ experiment, which I'm sure I'll be doing a talk on at some point soon enough here anyway. However, for the last couple of months, I've been stuck with a much more pressing issue, which is not being able to go outside of the house. I feel like you might have been exposed to it too. So let's go a little bit into why. So there's this thing, you might have heard of it. It's called COVID-19. I think it's some kind of disease. Bats, something to do with? It's something China Anyway, it's keeping us all inside whatever this thing is, and there might be a second lockdown, and everyone's justifiably quite scared. And naturally, when we all get quite scared, you try and latch onto like someone to aspire towards, right? And if we're talking about people being stuck in a box for a very long time, one of the first groups that comes to mind is the astronauts. We all want to be one. That's why we joined AstroSoc. I was disappointed that I wouldn't get launched into space at some point or another. And they're all very cool people. Like, look at this guy. He's very cool. So how can we be as good as they are, obviously, at handling lockdown? Let's just go and find out real quick. And that was kind of the thought process that led to me going on this little journey of discovery we're going to go on right now. So with that whole spiel out of the way, I'm going to go into a little bit of the previous research that I did, kind of going on from that idea, and some of the thought processes that were tinkering away in this head. And to spoil a little bit ahead, how those ideas really kind of fell short of what I was expecting. But first of all, we're objective people here, right? We're rational people. Most of us are from STEM, a few exceptions. So we like to put units on things, right? So how long is a COVID length of time? This might sound like a weird question. So I tried to rationalize it in the form of, I called it a standardized isolation from COVID unit, or a SIC. So the length of the first lockdown we had, from around the 16th of March to the 1st of September, was around 170 days. And by complete coincidence, really happy coincidence actually, the typical space flight, according to NASA, is around 180 days. So I called this one SIC. One SIC is one lockdown that we've currently been in, and it is also one space flight. The first space flight by the third Skylab crew, we'll be getting back to Skylab later, was around 84 days, or half a SIC. But the longest ever space flight of around 438 days, thank you to Valery Polyakov for giving me a statistic like that by existing, is around 2.5 SIC. To be a bit cynical, hello people from 2025 watching this video and laughing a lot, the days until a projected vaccine is currently projected to be around 12 months, or 2 SIC. So, putting cards on the table here, it's likely to be around 1 SIC until measures begin to be lifted, if a second lockdown hits, which, let's be fair, it probably is at this point. So with that in mind, the kind of lockdowns that we're going to see are quite comparable to the lockdowns astronauts have been through. So how do we try to not go mad? And on top of that, good job for surviving this far, by the way. Here's hoping for the second half. I should also add that I had nowhere to slot this in for reasons that will become very obvious later, but this is Paro, the robotic baby seal companion for the use of dealing with kind of PTSD, dementia, Alzheimer's, just anything that will result in increased levels of anxiety, and I've got to say, he would relax me a lot too. So fingers crossed that not only does he get used as they're discussing in future space flights, but also in everyone's houses, because I think we all need someone like Paro in our lives. So the reason why I had to throw something like that in there is going to become quite obvious in a second, because I start looking up tips that astronauts have given to dealing with that kind of isolation. And you get things that are quite generic. You're getting like, set yourself a schedule and do things at a specific time every day to give your life purpose. Be sure to talk to people in case you're not at some point or another. Make time for fun. You're getting the gist by this point, I assume. Start a hobby, work out, manage conflict, look at the big picture. And while you're at it, eat your greens, brush your teeth before bed, and don't forget to tidy your room. Your mother really worries about you in this day and age. So I was gonna focus on this as an idea, and it starts to get very gimmicky and generic and completely useless in terms of the information it was giving. Clearly because these people were being interviewed, and then there's kind of implications with being interviewed like that. But then I found one specific book. So most of this talk from this point onwards is stolen from the novel Psychology of Space Exploration, Contemporary Research in Historical Perspective, which is a really good read. It's also a stupidly long read. This book is trying to go into the psychology that needs to be in place within the next 10 to 20 years in order to get people to Mars. A trip which, I should add, will take either 3 sick to get there and back, or if you're looking at companies like SpaceX, is around infinity sick, because people will just be living there. So we're going to take this work that seems quite relevant to us right now, chapter by chapter. And I'm going to slip in a few little items of personal research, a bit of experience here and there, but it's mostly going to be applying this single text to COVID. And if there's one thing to take away, if you leave right now, there's the idea that we have this kind of image of astronauts as being a beacon of physical and mental strength. It's how I started off with this talk. But we do well to work out, A, what that means, and B, the kind of effect it can have on these people. So with that, let's get into chapter 1, which is called Psychology in the US Space Program by Harrison and Fielder. So this pair start this chapter looking at NASA's initial approach towards screening people. So this first of all starts out with physical tests, seeing how much people can bench, seeing if they'd be able to survive in a spaceship physically, and then goes into screening for particular traits that they believe will lead to people not being able to survive emotionally. So screening for what they'd call non-neurotypicals, people without a history of mental illness within the family. Also, as people with short-sightedness are just immediately scratched out of the equation. Anyone with anxiety? Gone. Bam. I'm very sorry. There's the quote attached to this that through most of NASA's existence, the behavioral sciences have been barely visible on the agency's horizon. Now, naturally, this changes because this quote is from around 1975. This sort of changes around the 70s and 80s for reasons we'll get to quite soon. But in general, there's this framing throughout the entire thing that NASA is picking people for the job and don't try and change the job for the people. And as we'll see soon, there's a track record of this going to repeatedly bite them in the ass. In terms of the psychology, not only is NASA not listening to the psychologists, but there's also the fact that the psychologists aren't that well developed anyway. For a start, data's quite scarce. There's only so many astronauts that exist. At first there was 1. So samples are quite small, though as we'll see later there are a number of situations that are in fact similar to a spaceship. You might even be able to name some right now. There's also the issue that NASA is quite privy with their data. By being an attachment of the US government, a lot of the data and statistics that they have are quite confidential in case of leaking to other people and the implications that could bring. There's also the fact that even outside of NASA, this field that we're looking into, known as salutogenesis, I've probably pronounced that incredibly wrong, is very untapped. When we think about problems with a person, we tend to think of boils and bunions that we can just jab a needle into, rather than the fact that a person is anxious. And without getting too into the nitty-gritty of this, it seems like at the same time, these issues are treated in the same manner. When we see someone with anxiety, we deal with it with tablets and going outside more and don't think about the circumstances that can lead to that as an issue. This is to an extent because most people aren't stressed, though I can't speak for everyone in that regard, much less myself. So in general, not only is this field of psychology underdeveloped at this point, but NASA's ignoring what little information there is there, also because of the issue of paperwork. And it's quite convenient for them too, but it leads to quotes such as this coming out in the paper. So despite this, the 1987 panel's assessment of the importance of behavioral issues Little progress has been made transforming the recommendations for research on human behavior and performance in space into action. The history of space exploration has seen many instances of reduced energy levels, mood changes, poor interpersonal relations, faulty decision-making, and lapses in memory and attention. These negative psychological reactions have yet to result in disaster, but this is no justification for ignoring problems that may have disastrous consequences. Furthermore, there are degrees of failure short of disaster and degrees of success short of perfection. If favorable organizational and environmental conditions can increase the level and probability of success, they are worthy of consideration. Which kind of sums it all up quite nicely there, really, doesn't it? One of the big motivators that led to this statement in particular being made by officials at NASA was the increase in crew size in a lot of these ships. So, as you'd expect, an increase in the crew size leads to more social contact on board, and hey, it turns out that these people aren't doing their job perfectly, and some of them aren't quite mentally stable. This didn't really show itself in Project Mercury, one of the first NASA projects, which just sent up one person into space, got them down, got them back alive enough to give interviews. This then gave away to 2 people in Gemini, 3 people with Apollo, and now we have around 6 people with the ISS. To link this back to how this book eventually gets to the idea of people going to Mars, we're expecting around groups of 8 to end up on Mars missions. But this still results in a team, even a team this small, with a diverse set of skills. You've got kind of a hierarchy starting to show up, professionals and not so, and you've got to focus on communication skills and people personing and screening. Finally, after 10 to 20 years of this shite. There's also the fact on top of this that an increase in the amount of communication technology available in a ship also helps. Astronauts are now able to not just talk to the 8 nerds they're stuck with on a spacecraft, but they can also talk to people on Earth who aren't scientists, which is honestly great. But enough being cynical about my own field, and probably most of yours as well. We should go on to chapter 2, which goes into kind of the first ideas that I was talking about here about scanning and screening for very specific kinds of people. This is again by Harrison and Fielder. So, as we've gotten into before, psychology has been ignored for many years at the very start of NASA, for the most famous explorations expeditions. And this is kind of because they proved that spaceflight didn't drive its candidates mad. Candidates went up into space, they came down, they were conscious enough to have an interview, and then NASA could just shove them in a cupboard somewhere to handle their emotional problems in their own time. The historian Roger Larness points out that from the moment they were introduced to the public, America's kind of enthralled by this virtuous, no-nonsense, able and professional astronaut, this tough man, who puts a human face on the grandest technological endeavour in history, and represented the very best that we had to offer. So again, we have this idea of choosing the tough people and not changing methods to fit more people. So why were people convinced by this as an idea? Well, it's good for astronauts to think that they're the best of the best. The book describes it as being a John Wayne image. You see yourself as being a badass. It's going to make you feel better when you get out of bed in the morning. It also cuts staff out, so it's good for NASA. Because why worry about what psychologists have to think when that's just more paperwork to have to deal with on a daily basis? And finally, it's good for the public as well. You can kind of lean on propaganda and help sway the public and the press away from potential criticism. Because you've got to keep in mind as well that the first NASA expeditions weren't exactly done in a bubble, which is something we're going to get back to quite soon. But before we get to how this completely blew back in people's faces, I've got another neat quote here. So from the beginning, the press was never motivated to dig up dirt on the astronauts. Rather, reporters sought confirmation that they embodied America's deepest virtues. They wanted to demonstrate to their readers that the Mercury 7 strode the Earth as latter-day saviors, whose purity, coupled with noble deeds, would purge this land of the evils of communism by besting the Soviet Union on the world stage. Today, people look back longingly to a simpler era, when good was good and evil was evil, and at least in memory, heroes did not disappoint. Which is it's just such a nice image, right? It's a nice romantic image. So how did this go horribly, horribly wrong? Let's find out. So the first issue we get to is Apollo 7, the 7th Apollo mission. This is a real eye-opener for a lot of the people going on this flight. They meet cosmonauts on ship for the first time. One of the people who, the captain of this mission was Wally Schirra, who was a little bit miffed himself because of his friend burning alive in Apollo 1, which led to a number of people monitoring him, seeing the safety of his crew as his prime concern, woe betide. You'll see a very particular picture of some NASA higher-ups here. But anyway, this kind of culture shock of meeting the cosmonauts up there, seeing how they treated their staff, as well as him and his situation, led to, let's just say, some tension between him and staff, which was severe and public to the point where him and his crew never flew again. In fact, he did a lot of sinus commercials after this. So Wally's off marketing headache relief, and at the same time, Skylab 4 is a mission that exists, Skylab being America's first proper space station. America are very proud of Skylab 4 at this time, and they're getting confident with their ability to get people up into space, so much so that they've concluded that tough stuff doesn't need free time. So they start shortening meal times, they increase the speed of setup, and worst of all, as we'll get to later, they don't give any of the astronauts time to watch Earth. This kind of comes to a head around the 27th of December 1973. This is quite a publicised incident, the Skylab 4 sit-down strike. Crew were noted as being irritable, hostile, grumpy, and arguably angry about overwork. This kind of came to a head in the form of the book Self-Care, Astronaut Care for Exploration Missions, kind of a watershed. At the same time, a lot of comments were coming out about Mercury, which was considered a spam in a can mission. I always like that quote. So, spam in a can in a corner. What do we learn from this? Well, we learn that the tough stuff mentality doesn't work, and it didn't work for the people who were considered tough stuff, who ended up in tense enough situations that they started to break down. So be emotionally open, realise that being strong isn't what gets you through lockdown, and also keep in touch with a lot of different people, because as soon as you start meeting some cosmonauts in real life, you might start to have a bit of a breakdown. Also, check with your landlord that your room won't kill you or set you on fire. That's probably a stress relief. So we've talked a lot about how things started to fail, but how are the psychologists doing at this time? And we're going to get into that with Chapter 3, Earth and Analogues to Space, the first chapter not written by the original pair, by Bishop instead. So, as we got to before, sampling people in space is quite difficult because there aren't many of them, but it turns out there are some things on Earth that are like a spaceship. So I'd stick around and answer for questions, but I'm already going to be running over the time schedule by quite a lot, so we're going to go over a couple here. So, deep sea divers. Yeah, they're in quite isolated conditions, but they're bad to test with, because as the paper concludes, they're also in kind of the Navy industrial complex. They've still got this tough stuff mentality, so if you're wanting to work out ways to counteract that, they're a relatively bad group to deal with. Arctic explorers? Yeah, sounds pretty good. Most of them are physicists. They're not exactly, well, physicists and other groups like that who aren't exactly chosen for being tough stuff. I mean, I'm not exactly the strongest person in the world. Astrophysicists? Yeah, a lot of them were starting to spend a lot of time in places like Chile, having observatories in places that had lower and lower levels of light pollution. So kind of watching them in isolation would be a good method of examining similar circumstances to people in space. Canadians? Yeah, they're pretty tough. The paper goes to a length to conclude that just most Canadians live in isolated conditions, or at least isolated enough that they'd be useful, and I just find that quite funny. That leads to a couple of analogies for space exploration and isolation being put in different places on Earth to test for future adventures and expeditions. So from left to right, we've got MDRS, an experiment in Utah owned by the Mars Society. We've got the Horton Mars Project, which is located in Devon Island, Canada. FMars, which is also located in Canada. A lot of desert areas in the Canada areas. And Concordia Base, which is located in the Antarctic. All of these have been collecting data for God knows how long, but they're all quite promising as well, but they're collecting data quite slowly.
These are large data sets that we need, and each cycle of people inside these ships is going to take around 6 months with some anomalies, it's going to be quite difficult. So hopefully these come out with results in time for future Mars missions, and at the very least, hopefully there's some findings that come out relatively soon that can help with missions in the meanwhile. Enough about astronauts, let's get to the bit you're all actually here for, taking pictures of space. Patterns in crew-initiated photography of Earth from the ISS. And as you can see, researchers were a lot more interested in this one. So we've got Robinson, Slack, Olson, Trenchard, Willis, Baskin and Boyd, all different academics, all different universities, all very interested in taking pictures. You know what this chapter's about. You've already seen pictures of space. You're going to see pictures of space soon, don't worry about that. But this is about what you'd expect. Though there are a couple of interesting quotes and a couple of interesting hypotheses. A crew member with a camera in hand was more likely to take self-initiated photos as well as requested images. Who would have thought that astronauts like taking pictures of space? More images would be taken before extraordinary events such as docking is also supported. It turns out that we can immediately conclude here that it's a good stress relief in those sorts of times. A couple of hypotheses weren't supported though. There weren't more self-initiated images taken on weekends, because I don't think astronauts really have weekends. Space is always a deadly place to be. There also weren't images taken of areas of personal interest. Astronauts found all of Earth to be quite an interesting place to be, which is something we'll get back to quite soon. However, we did see that images would be taken differently across several missions, which kind of shows how this is a very good method of staying sane out there. I should add that this book goes into huge amounts of detail about like focal length, all kinds of different conditions and hypothesis testing. This is a really good book. But anyway, here's some pictures of Earth. Ooh, I think you're kind of legally required to put some nice pictures of Earth in most astrophysics presentations. We've also got a graph, which makes this a scientific presentation. Here we see for large missions like EVA, for example, I don't know which one that is if I'm honest, you see a very strong correlation towards the end of the mission with pictures being taken, though that's not to say that there aren't a lot of pictures being taken anyway. But this is what they used to support the hypothesis that in extraordinary missions, extraordinary circumstances, more and more pictures get taken, which is interesting. So that's chapters 1 through 3, which are quite interesting chapters to get into. Chapter 5 goes into something which is a little bit less relevant for COVID, which is using flight simulation booths and testing. I don't think many people want to be in a COVID testing booth. There's also chapter 6, 7, and 8, which from different facets and points of view go into the idea that more diverse crews tend to make people happier. Shocking thought. Although it does interestingly conclude that, from NASA's perspective, demographics are moving quicker than culture is. So a lot of the older people in NASA aren't quite catching up to the times, and they say that that needs to change before we get towards Mars missions. Before we go on, here's a picture of one of the spacecraft simulators. Ooh, isn't that nice? I'd want to live in one of those. Anyway, so I've kind of built this very morbid image of NASA up to this point. I go into these books and these pieces of literature thinking that astronauts would be able to give us advice on how to deal with isolation, and it turns out to kind of be the other way round. But this is the part of the presentation where I'm supposed to tie this into something very inspiring, kind of build up this plan for how to deal with COVID and isolation. So I'm going to try and do that. And to do that, I'm going to talk about Karl Marx. Please don't stop the video just yet. I'll get to the point. There's this play called Young Marx that I was watching during lockdown, and in it, Marx and his family are making dinner one fine day, and he's making bacon and eggs, as you do, and he has this moment of revelation. So he turns around to his family and he says to them, "I don't know who laid this egg." And it sounds like a surreal statement, right? Because like his kids would turn around to him like, "What on earth are you on about, father? Restore the means of production to the workers, please." But he talks in some of his later texts, as well as in the play, about this idea of commodity fetishization. Commodity just being anything that can be bought and sold and is not just immediately consumed. But there's this idea that back in the days of yore, if you collected something from someone else, you knew exactly who made that thing, who produced that thing, who they passed it on to. And as we've started to reach later and later ages with the Industrial Revolution and going into capitalism as a more robust ideology, we've started to replace that more and more with everything having a price and more or less being a black box. And there's debates about like food standards and whatnot. But in general, it makes people feel less connected to other people through the things that they own, which is quite a negative thing. But astronauts managed to circumvent this a little bit by being connected to the technology, knowing the research that's gone into their work, by being able to contact their family, by being able to contact other people in NASA, and from just being able to look at Earth, this tiny blue speck in a mote of dust, and be like, that's everyone I've ever met, they kind of managed to circumvent this idea. They stop thinking of the things they're surrounded by as objects and start thinking about how they connect to the greater scheme of things. A lot of astrophysicists call this the overview effect, NASA does at least. The sensation of looking at Earth and seeing it as a pale blue dot, and at the same time everyone you've ever been connected to. And the number of just things and people and objects and social connections through those objects that have made you where you are and who you are in space. It's a good thought. And this kind of wraps into what would have previously been a very cliche conclusion and kind of even matches some of the jokes I was making at the start of this, but it's kind of been made more robust now, which is that you don't need to be tough to make it in COVID. On the contrary, toughness mentality kind of ruined the first few American space missions, and we're only just starting to work around this as an issue. But we do find that keeping connected with other people and remaining emotionally open in tough times is key. So I'm going to kind of wrap this up with a couple of last little bits. First of all, there's two very nice quotes from the end of the book, which I, again, recommend a lot. The first of these is that effective behavior doesn't stem from good people. It's called forth from good environments. Surround yourself with good people, make sure that you are comfortable and that you can open up to these people, and you will survive. And on top of this, something to think about during the second lockdown is that it's not enough anymore to design to survive. The time has come to design to thrive. So with that being said, thank you for listening to all of this. I'm sorry if everything seemed quite clustered and hectic. It has been clustered and hectic in terms of starting the PhD and all of that. But thank you again to AstroSoc for allowing me along. I hope that I can do a talk that I might know something more about than experimental psychology at some point in the future. Hopefully with British Science Week or Space Week or whatever. But until then, I hope this has given you something to really mull over, and I hope there's some questions. I'd like to talk about all this and see how everyone's doing. So thank you. Cheers. And stay safe out there.